So we are back and we are up and running again. So here we are right here in our Protastructure where we are now going to be designing for our powered foundation. So you can see here we are now on our story zero level, which is basically um, the base of our powered foundation. So anything that you are going to be modeling for your foundation has to be done on this story zero level. So you cannot model for your foundation element in any other level apart from your story zero level. So this story zero level is basically the base of your pad footing or your pad footing. So to now insert a pad footing, simply select a column and right click and then say insert pad footing. Just click on that once. So the pad footing editor dialog is going to appear. So here you have the option um to insert your pad footing or to do some necessary calculation and adjust the properties of your pad footing. So just click on that, wait for it to come up. It's going to come up very soon. Yeah, it is here. So here is our pad footing calculation or design dialog. So here the first option here is just basically the label of your pad footing, and here we have the depth of the pad footing is by default set to 400 millimeters. So you have the option to change it to whatever depth you want. Let's leave that as 400 millimeters for now. And here we have our tapper height to be 0. So we also have the option to change that in our general settings tab. So we are going to be covering all that in our advanced classes again. So here we have the concrete cover to be 50 millimeters. So the minimum concrete cover you should be using for your foundation elements should be around 50 millimeter. So that should be the minimum, knowing that your soil can have huge bad effects on your reinforcement, and that can even lead to collapse. So here we have the LX and LY, which simply means the length and width of your pad footing as well. So you have this option to make sure that your pad footing is square. So let's leave that unchecked so that it can be rectangular. So you have this eccentricity that we have been talking about as well for your pad foundation. So here we have the design status that says design is successful. So all this can be changed if you want. For now, let's leave it just like default. So here is a preview of your pad footing or your pad foundation. So here we have the Q4, which means the loading on this edge of your pad footing. Yeah. So we have the Q3, Q2, and Q1. We have the top view and we have the front view. We also have the 3D view as well. So this is basically the three-dimensional reinforcement view of that. So you can see that. So you can change that. You can pan that in any way you want. So that is that. So these values we have here are just basically your earth pressure values that are acting on different corners of this pad footing. So when you are finished doing that, click on OK, and in few seconds, yeah, we now have our pad footing successfully added here. Now go to your 3D view to see that. So let's rotate this so we can now see our pad footing have been successfully been added here. Like I said, this class is not going to take much of our time because the procedure to do all this are pretty much very simple. However, there are more advanced ways that we can now explore our substructure or our foundation. There are many things that are need to be taught that I need to show you guys, but due to our time constraint, we may not be able to go into all that right now. as you can notice, we haven't designed our slab, and we are not going to cover pi foundation design and rat foundation designs and all that in this training. So that is why the advanced training again is very important. So let's continue adding our pad foundation. Simply select a column again, right click and then say insert pad footing. When you do that, you're going to get this option again, and when you scroll down, you're going to find out that your design is successful. Again, say okay. So for your assignment, you are going to be repeating this same process again for your assignment. So let's add a part footing here. Right click and say insert part footing. Say okay. So you are going to find out that by the time I now insert this part footing, this the area of this part footing is going to be clashing together with this one. So what I can simply do is to add a combined part footing for the two columns. So to do that, let me say Ctrl Z to get rid of that. Now select the two of these columns at once, right click and then say insert part footing. No, that's not correct. When you have now finished selecting that, right click and then say insert combined pad footing over here. Click on that. So you get the option to insert a combined pad footing. So here is the 2D preview of that. So we have the LX to be 1600 millimeters and the LY to be 2100 millimeters as well. So check the 3D view to see what the 3D view looks like, the reinforcements as well. So we have this option here that says rebar. So here we get the option to change the rebar properties and the rebar spacing and all that. You can see the spacing of the rebar on X is 250 millimeter, and the diameter of the reinforcement is 20 millimeters as well. You can change that to 16 or any other um, desired diameter for your bar size. So for now, let's leave that as so, and then say okay. Now go to your 3D view to see what it now looks like in the 3D view. Okay, here we have our combined pad footing. You can see that our pad foundation or your pad footing is showing the green color as well, which simply means that this footing successfully passed the design. So that's pretty much it. So for your assignments, like I said, this class is not going to be that long. So for your assignments, you're just going to do the exact same thing that I've just done. Just simply go to your analysis tab, building analysis, perform your analysis and all that, and then come back to your story 00 level, and then insert part footing for the rest of your columns, for all the columns in your model, so that you are going to have something that looks like what I previously showed us in the beginning of our second class. So that's pretty much it for our column. Someone said, is it possible? Someone said, is it possible to have combined footing on three columns? Yeah, it is possible. You can do that. So your part footing are necessary for columns that are closer together. Yeah. So you don't do that for columns that are very much distant columns. So but let's just try that so that we can just at least see what it's going to look like. So now let's select these three columns, right click and then say insert combined part footing. So you have this option to say insert pie cap or insert combined pie caps as well. So say part footing, insert combined part footing. So you're going to get this option as well. Go to the 3D view to see what it's going to look like. Just the same way um you have this. Just the same way you have the floor plan and view. So go to the 3D view so that you can review that. So this is the combined part footing. You can see the way it's looking. It's not looking very, very, you know, professional. So that is because the columns are widely spread out. They are spread out, that they are very much distant from each other. So that's why you have it just like so. So let me remove it for now. So another question: what's the maximum distance you can combine the footing if of more than one column? The maximum distance. There is no maximum distance. So it's necessary only when you have columns, when your column bases are clashing with one another. So if I insert a part base here and is now clashing with this part base, it's better that I delete both of them and then insert a combined part footing. Are you following? So that is basically the answer to that. So when is the assignment due? The assignment should be due on Sunday. I would advise you to try as much as possible to complete your assignments as early as possible. So by doing that, you're going to encounter different mistakes and different errors and all that. So when we now come for our um review session on Sunday, you are now going to have the option to ask questions. So when you have now encountered mistakes and all that, you are going to be asking a lot of questions that you are now going to be cleared on. Okay. So Engineer Chinatulun Jidofo, what if the footing size is too large? Now that is where our advanced session comes in. So when you are getting the footing size to be too large, giving you values like 10 meters by 10 meters and all that. So it is not reasonable at all. So what that simply means is that your part foundation may not be suitable for that structure. So it simply means you now have to change to a suitable foundation type, change to another foundation type. You can consider using the strip foundation or strap foundation, or you can go as high as using your RAS foundation. So, but I don't think, yeah, you can go as high as using your RAS foundation depending on the um, bearing capacity of your soil. So we also have that option to set the bearing capacity of our soil, the factor of safety, the bearing capacity, factor of safety, and the bearing capacity that will be required for different types of foundation design. Are you following? So we are going to be covering all that in our advanced classes. Okay. So more questions is what I need. What's the maximum distance? Okay. Is it possible to design other type of foundation like raft or pile for this building? So it basically depends on the weight of your structure. Now this is basically, you remember that you selected the loading imposed loading for our building as the residential building with communal areas. I mean, your residential building rather. Okay, so when this building is going to be imposed by, it depends on the activity. So if this building is going to be imposed by cars and others, maybe it's a building that is going to be used for parking cars or shopping areas, you are going to find out that the loadings on this building is going to make it to be very heavy. That is what is going to cause the pad foundation size to be too large. So what that simply means is that you are going to change the type of foundation. So the type of foundation that you are going to use depends, one, on the bearing capacity of your soil, the type of soil you have. It also depends on the size of your building and the results you are getting from your axial load, your axial load result. So, but before we do that, let's show you how to determine or how to find the axial load value of your columns. So simply go to your display tab, and then in your visual interrogation, go to your column display. When you have done that, you are going to find different columns here. Check the axial load here, and let's leave the bending moment and shear force for now. So now select the axial loadings that you want. So let's select the dead loads, let's select live load, and different loading combinations as well. So we have the G plus Q, and we have the G plus Q NX. So let's select all these most of these loading combinations, and then when we say OK, we are going to notice immediately the axial load reports or values are showing in our background. So zoom in to let's see what it looks like. So we have here in this one column 4, the dead load, the axial dead load on it is 382.9 kilonewton, and the live load is small, 25 kilonewton. And here we have the combination one as 516 kilonewton, 516.1 kilonewton. So it depends on the use of your building or on the weight of the structure, depending on the kind of imposed load that was now mounted on that and how wide apart your columns are now spread. So it's going to be giving you higher axial loading values, even up to 3,000 kilonewtons and all that. So it's now going to affect your the type of foundation that you are going to choose. So I hope that is clear. So our next question: can the YouTube video be available early? Okay, so we normally have um problems due to networks uploading these videos on YouTube. So we immediately I finish this class, I'm going to start uploading that. That is how we do that for our previous classes. So we start uploading that the night we finish this trainings. So it's from the video resolution that we are using to record that, and all that is affecting the speed of upload. So we can do that as much as possible. So what is the difference between pad and strip foundation? So your pad foundation simply looks like this. So I've designed some buildings that are on rest foundation and all that. So here is what your pad foundation simply looks like. So your strip foundation is also connected by beams. It's more like chaining your columns or your pad foundation. So it's also connected by beams. So you are going to see beams running every inch of the column everywhere you have your pad foundation. So your strip foundation is connected by beams, and your pad foundation is not connected at all. So we are here to see the attendance links. So engineer Samuel Joshua, please help me with the attendance link again and the course code as well. So I would like to entertain questions. So if you have been encountering any difficulties with respect to our classes, I would like you all to you know throw in your questions right now. So another question: is pad connected by blocks? So okay, what usually happens in our traditional construction sites where we now insert blocks in our foundation? That is just basically to contribute to the strength of our foundation. So blocks are not are not very strong members to be supporting your building. So what really carries your building are not the blocks that are inserted in the foundation. They just help to draft the layout of the of the building. So blocks don't even contribute to the does not even carry the loadings. So it's basically your columns and then your foundation, theoretically. Yeah. So we are going to be doing that detailings. So okay, here is a detailing that I recently did. So this is a building that is sitting on pad foundation, just like the one that I've shown us. Yeah, this building now sitting on beam graft foundation. There are two different types of graft foundation. We have the slab graft foundation. We also have your beam graft foundation. So here is the structural design of that building. It has been successfully completed, and here is the first, second, and third floor slab, beam, and column layouts. This is what the column layout looks like. So in our advanced classes, we are going to be going to the extent of teaching you how to do the detailing. So I performed the detailing using the AutoCAD software. So there is a detailing that is also being provided by Protastructure, that is on your Prota details. That detailing is good, but it may not be good enough. So this detailing was done even to international standards. So if you are taking freelance jobs and all that, and you are to prepare a detailing for people outside the country, so this is standard that is actually recognized internationally for your detailing. So we are going to be we are going to try as much as possible to teach you all that in our advanced classes as well. So here we have the first, second, and third floor beam details. This is what the beam details looks like. And here we have our slab details. You can see that this is what our slab details looks like. And here we have the roof beam and column layout as well, and then the roof beam details as well. So we have already done the column details as well, but I did not include that um in this AutoCAD file that I'm showing you right here. So that is that. But for your basics, if you want to know about the details, or if you want to know how to open up your details, simply go to the drawings and reports tab and then say Prota details. When you click on that, it's automatically going to open the Prota details environment, your Prota details software. Then your detailings, your detailed drawings are going to be automatically imported to your Prota details, depending on how you set that to happen. So we may not be able to cover all of that in this particular class. So we are going to be covering that in our subsequent classes. So in our group, I will advise you to throw questions there. Even after our training has been concluded, we are going to go as much as possible to be, showing you some, guiding you if you need any questions or any guidance. So that's basically that.